all hungover.
Yeah.
Now it's more like some people are like going tomorrow in the morning, so they have to like they probably want to buy some souvenirs there.
What about Kenan? Where's Kenan? He's probably still asleep.
Oh, Kenan is probably sleeping.
Yeah.
So, like,
Kenan is a true legend. He sleeps all night.
Yeah, and all day.
Then he comes to class for 2 hours and takes another 3 hours nap.
And then after the lecture, he gets like 2 hours nap, and then he's up for 2 or 3 hours, and then he's all so tired.
He essentially sleeps 1 hour per hour class.
Yeah.
Insane.
But it's he's rested.
No, he's never rested. I don't know.
No, he was rested after 10 hours non-stop sleep. It was that was good rest. But of course, he went for a nap.
But yeah. He didn't say it.
Okay, so we can start. So today we're gonna look at HPC, what is high performance computing, and TensorBoard. Probably if you told that you've been doing something in TensorFlow, you know what is TensorBoard, right?
No.
No, okay. So one of the things about AI and all this stuff is that you can like train your models, but for now what we've been doing is we're outputting all the stuff in Matplotlib, like some pictures, printing out some lines. The thing is, if you train like 100 models and a lot of stuff, you need somewhere to keep them. And you want that information to be available. So we'll be looking at one tool particular, TensorBoard. And yeah, it's an interesting thing because there are a lot of machine learning frameworks. And each of them has like something to visualize the data, to store the data. But nothing is perfect. For example, TensorFlow was kind of bad, the first one. So they stole a lot of ideas from PyTorch. Now they have a lot of mess because it's TensorFlow 2 with that you can put breakpoints. It's called, I think, eager execution or something. And
what would you say? What's the better framework, PyTorch or TensorFlow? Because it seemed quite obvious that Eva prefers PyTorch.
For me, 100% PyTorch. Because it's like
you can dynamically adjust the model.
Yeah. Even if you want in a model to put like if statements or something, you can do that.
Oh, okay.
In TensorFlow, you can't do none of that.
So
it's like it's more for like better for developing new stuff, testing out stuff, but for like using in production, both of them are bad.
Yeah.
Because in production, you want something that is faster than Python, probably. So you can move to another frameworks. And there's
Because I always thought PyTorch is almost exclusively for research and TensorFlow is rather an industry standard.
It was in the beginning, but if you look at like for example, GitHub repos or something else, it's like first it was like TensorFlow is a lot, PyTorch is just starting, and now it overtook it like massively. And they have everybody together have developed a format called Onyx, and the idea is that you can port your model from one framework to another. So that means that you can train in PyTorch, and if, for example, you have an app or something that is using TensorFlow or the Keras or some Microsoft stuff, or even like Cafe 2 or Onyx runtime, some of them are for C++. So if you want something like really fast, you can just port the model afterwards. So that is the best thing, because it would be bad if you need like to execute the model in the same framework you develop it on. On the C++ side, it would be pain in the ass to develop new model, like all the stuff you want to save. See, it's like, so this is the good stuff. And for saving the results and all that stuff, PyTorch has a tool called Wisdom, but the problem is that it stores it in runtime. Like you open a server app and it stores all the data, and once you close the window, all the data is gone. So it's kind of bad. That's why we're going to be looking at TensorBoard. It's storing them in data, and you saving on the disk. You can just run an app and open it on the web browser and see all the stuff you have. So afterwards, you just run in the background. For example, you have like home server or like spare PC with the GPU. You just put your models, leave it for the weekend, come back Monday, you just run the TensorBoard and look like, oh, 50 runs have finished. You can look all the learning curves, all the images you saved. And for example, here you can see some embeddings.
Can you also visualize your PyTorch program in TensorBoard?
The model?
Yeah.
I think you can, but it's sometimes not very good.
Or do you have to convert it first using RNN, for example?
With that, it's how can I show?
So what should I do if I now see TensorBoard for the first time? I really like the visualization, but now I want to work with PyTorch and it doesn't work.
I will see. I think you can visualize, but it will look something like this, and it's kind of a huge mess.
Yeah, okay, I'll just wait and maybe ask later.
It's the same stuff with I think TensorFlow. Sometimes it's a big mess how you save it. Like when you save and tries to visualize it, it's like the app is called, I think, Netron.
That's for PyTorch.
It's for everything. It imports only Onyx, so you can write in TensorFlow PyTorch. In the end, if you want to save, just save. How you do it? You just construct your model, make like dummy data, run through it, so you know all the gradients and all that stuff, and then it can save. And the good stuff is that, as we've been writing in PyTorch, you can make those sequential and module lists, and you can name them. So, for example, you don't want to see like this, that it's convolution, relu, convolution. You can bunch them together and call like it's like, as we did, I think you did the ResNets.
Okay, so I was talking about it with Stefan the other day, and he said if you create a sequential model, you can't see the shapes of every single layer you implement in your sequential
If you...
And that's what you can use Netron for, right? To get the shapes of each individual...
No, the thing with sequential is that it behaves something like TensorFlow behaves. You can stop it inside. But for example, here you have a huge model, like we did the ResNets. It has a lot of layers, it's really deep, and you don't care about every single convolution and every single relu. You can bunch them together in one package like res block, and it will show just one res block here. Like, and then you have res block, some other layer, another res block, and stuff like that. You can make different abstractions. So we need to install some stuff if you're using your own laptops. First, I will open a task we need. So basically, I prepared the template from the stuff you made yesterday. And the first thing we need is to download it and try to run it and see if we have all the needed like libraries installed. I will go and show. If you run it, it should be executing without any outputs, just like iterating through the epochs and printing out results. You need the TensorFlow and tensorboardX. The idea is that TensorBoard is packed together with TensorFlow, but tensorboardX is like community-made package that you can use with PyTorch. So you should see this output that I have now. It's just working. Everybody can run the template?
Yes. Can't install this Captcha.
Okay.
Because I don't know, I've already installed the Captcha module, obviously, but it's not running.
Okay. I will go and check for those who's not working.
So I can't install the Captcha thing because it's already installed. But not that long ago. You should do that longer.
No, it's very the same efficiency. I was learning on the best.
Maybe you can try to install different
And I saw
yeah, try it again.
Yeah.
And after that you need TensorFlow and TensorboardX.
That works.
Okay. This is the template, right? How
Yes.
it's going? Everything's going?
No.
Okay. I just run the template and see if it's working. Maybe
Yeah, maybe I should only change the computer again because I have all the time problems that PC isn't recognized to the GPU.
and you just change this to CPU. Yeah. You can make it to check it automatically. Running. Good. Great. So from yesterday, the output looks something like this. And this is all we have. We have the loss curve, accuracy curve, and some output images with the ground truth and prediction. What we want to do is to make it accessible anytime we want. For example, now I just close it and I can't access it anymore. You need to save them. There are multiple ways to do it. Like the most basic stuff is just you make with the matplotlib, save the images on your disk. You can plot stuff, save it on the disk. You can write the data if you want in a CSV format or something else that you can open with Excel and see all the stuff. But yeah, one of the best things that we can do is use the TensorBoard because it's much easier. Actually, in day-to-day, like training models, I use TensorBoard and the data in CSV format because if you have like hundreds of runs, it's like really too hard to see in TensorBoard which one you want. So you just see in the Excel, like run number 20 is the best, and you just open it and see it on the TensorBoard. So basically everything is the same. One thing I added is this TensorBoard summary writer. It's like from the package you installed from TensorboardX, but it had some bugs, so I fixed them. It wasn't saving all the data correctly. And if you run it, it just goes, nothing is saved, nothing is happening much there. So we can go here and start step by step. So first thing I will show here, you create an instance of this summary writer and you create a path. For example, it will be, if you're running in this folder, it will create a sequence, how you call the sequence name, and then you can have multiple directories for runs you want. It will create these folders automatically and save there. One thing we did, I changed is that I added a dictionary called metrics, where I have loss and accuracy. We're using a dictionary because it's the format the package supports. Now we can simply add few lines. You can summary writer, add age params. The idea is that it's all the stuff you can configure. On top we have the argparse. If you look here, you can call these hyperparameters because maybe you want to run with 10 different learning rates, batch sizes. Here we have the input captcha width and height. You can run tests, seeing maybe that 128 by 64 is not the best one, and we can search for a better one. So we want to log all of this stuff. So we can add age params dict. What we're gonna put there is args. I can put it like vars and in parentheses args. So arguments are in the object type namespace.
Where did you get all the lines from? Because my template only has 207 lines.
What?
Your template seems way larger than it's the wrong one.
It was probably yesterday's template.
Yeah, it is.
So first thing we're gonna add is all the args. Maybe we want to see different configurations we run. Next thing we need to add is called matrix dict. Oh, wait, what happened? Matrix dict. We created the matrix mean that we're gonna pass there. As the name, we're gonna pass args run name, and the last one will be the global step, and it's the epoch we are currently on. And this tensorboard writer does it approximately like 2 times a minute, but if we want to see the data immediately, we can just write summary writer flush, and it will write all the buffer to disk. We'll add 2 different things, but first, if you write this, you can run it. We need like at least 3 or 5 epochs to finish so we can accurately see what's happening. Okay, for me, some are done. It's running for everybody, or there's some problems?
Yes, they can't import the package.
Okay. Warnings? Warnings really don't matter, I think, if it's not errors.
Yeah, because of the
You can write from and if you scroll up, and you can just open terminal or run. And you need tensorboardX, not just tensorboard. Okay, that's a problem with the Okay, well, going again. Okay, actually it's installed now. It failed on the start, but you don't need. What's the problem?
I can't import the Captchas image. I don't know why.
Okay, you're running it in conda environment or
It's I think I have both installed, so maybe try to download by conda.
yeah, it will take some time to get it.
Yeah, at least would be end. So that's the main thing I installed.
But on most of the tasks, you're using the environment from virtual environment like the pit or conda environment. When you're running,
What can I see?
you need to go to preferences, settings, preferences, yeah. It's like project, interpreter, and here, okay. This is what we've been using for all of them, or is it more than five? You have but yesterday it worked with the capture.
I think it did, but now it's not working anymore. I don't know if they changed something.
No, it's the same.
Yeah, but yesterday it worked. I mean, it was running. I don't know if anything changed or something.
Okay, and just pip install doesn't work, right?
Yeah, maybe I would just type down the code and I would try to get it somewhere running.
Okay. That's not right. And maybe you can try with the Anaconda environment. You can install, right?
It's conda install, right?
Yeah.
Okay. I can try. You can go on. I would just
Okay.
let you know.
So basically, now we have a few epochs finished. We can change. I will try to show the terminal from this. What's happening? I'll go here. So it can go. We need to write to open the tensorboard. So what we write now is in terminal where you have all the stuff installed, you just write tensorboard. If you run it just like this, it will show you that you don't have any parameters. It will not work, but we can copy the path of the tensorboard log dir, and you can write the absolute path to the run you had, like this. And it's not happy because I made a typo. Like this. and it will show you that the local server is active at localhost and the port number. I will put this image in Jamboard for you to see. So this is what you needed to run. Now I will change this one to what we need. So if you want to copy something, you can just click here on the side where you have this stuff. Just click here with the right click and you can copy path, the absolute path, and write it in where you need. You can click here, copy path. It's not showing. It's not showing. It's not showing. Right click on the sequence and run. I can open my terminal here, for example. We are here.
So where's the sequence? Where did you get it from? Because I only have the script.
You only have the script because you can't run it. You can run the code. It will generate the directory with all the stuff you have inside. And what it makes here is events out TF events, and you just need to show the path to it. So we can write it. Maybe I can do it in here. Maybe it's seen better. So tensorboard, you add log directory, and you just add the sequence path. And this is what we could see now if we go to the localhost address. It copied again over. Sorry. So the address I will put in Jamboard for you to see too. So you should be able to see the results like this. Is it working? No.
Should it open like after we run the program?
Yeah. After you run the program, you will have it will generate a directory called sequence and run something like here. And you have multiple. If you go to terminal.
I mean, I didn't open.
Yeah, open Anaconda prompt. You will need to open your Anaconda prompt. Activate your environment.
I never worked at Anaconda.
Okay, I never worked.
Yeah.
You can check how is the setup for all of this. It should probably be the same, right? Yeah, it's called environment. Okay. Then we can go through this together. Yep. Okay. Doesn't because it's not installed. We can go to the here. Copy this command. Install tensorflow. And just copy here as well. It should be running afterwards. So let's go step by step. In here, when you had the run the model, do you see these directories? Sequence on the left, you can look, and run, and there's like tensorboard events, like file. Do you see them? Yes, no? You don't see the file? You don't? No, but in the PyCharm, if you look. In the PyCharm, you can right click on the sequence, and there is like a copy path, an absolute path. You need to copy the path to the sequence folder. And after that, I will open my Anaconda prompt. I will just open another one. This.
We are copying run the events.
What?
We are copying path the folder of run or to the events file.
To the run. This is on my screen. So now you need to activate your, it's like the command is conda, activate. For me it's called conda, and but for you it's called environment. You just need to activate environment. Conda activate and then environment. After that, you have write command tensorboard log dir and just add the path you copied. And if you run it, it should show the tensorboard some version at localhost 6006.
Jamboard is not recognized as internal or external command.
Then you need to install. You can go to the top of the template. I will show.
And there's
Pip install tensorflow and pip install tensorboardX. And tensorboardX should have been installed if you've been if you could run the code. Then just install tensorflow.
This was from install something here or no?
I installed TensorFlow over the navigator and then started again and then recognized TensorFlow. But because before it was like, okay, it's not installed.
This.
Maybe you can install from the navigator and install with the pip command. Are you going? Okay, this is good.
Okay. So you need to open the Anaconda. No, you need to do all that. Actually, then one. This, and then you can go tensorboard, that's the program, log directory, and here we can copy, for example, this folder, and you'll see it's working, unfortunately not. We need yeah, but you should see some data. What can you do? Just the virtually not to the run back to the sequence. Maybe you have one example, because maybe you just copy the path of something you stopped already. Now you can go refresh, and you choose okay. Working or no? So I was right. Conda or no? The sequence? You need to run. You run the code. They are comparing. I think it's fine. It's almost level. It's almost level. Today I'm going for a head burger. Even if it's I'm just coming out in the middle of volleyball match. I'm going to be running from the I'm going to be on the bench. No matter what. And so it's going to be great. I have to take the role from something.
slightly better.
Yeah. For me, I don't know the term. No,
Yeah, that will help to install it. But
I mean, I want this on the best.
yeah, but let's see this small.
I would be IT guy for working, wage. For the first 3 days.
Now we can go to the page for local host. If we will try this and see what
So I'll quickly add the stuff to the that we added for argparse to the Jamboard. So for somebody who's it's not working, so they can write it later if they need. Now we can quickly add a few more things. One thing is here in the end. If you scroll down, there's a to-do. What we're gonna do is again call the summary writer. It will be add figure, and here we will add figure equals fig. What will be that? We can add tags how we want to call. I will call it with a string of predictions. And as well we add global step that is epoch. The picture is the same we had printed yesterday out. I will just I modified a bit so we can save it to the tensorboard. I put a screenshot up in Jamboard. We will write another thing. We have another to do after the printing of the results. Okay, so here we write embeddings labels equals. I prepared some data here as a list together of the embeddings. The last layer, the output is like multiple classes, and we will try to project them and see them in 3D space how they look. Hopefully it's something good, maybe not, we'll see. But for example, there are some models when you care about the middle layer, for example, if you want to squeeze an image to some latent vector and then unsqueeze it, you can see the middle part. Maybe there's some interesting features. You can see like how it distinguishes like red colors from different colors. For example, using these embeddings, I think one of the Amazon models that were analyzing comments learned how to predict like the mood of the people and the sentiment, but the task was something completely different. That's why these things are interesting. We'll see how it works now. So here we add list. Then it's zip. We will pack them together. We need to add a star and log it with labels. And what we add again is summary writer what we had. Add embedding. We need to add the data. It's a NumPy array from the embeddings. The metadata for us is a list of the labels. So we know for each individual embedding what was the correct class, so we can see. Here we can add a tag. I will just call it logits. And again, the same thing as global step. We add epoch. This screenshot as well is in Jamboard if you need. Okay, we will go through this. So we wrote 3 places where we add to the summary writer. In the add argparse was the graphs you saw on your PC, like how the accuracy is going up, the loss is going down, all that stuff. Here we are adding the embeddings. This is the output from the last layer. It's like dimension how many classes we have. It's like 30. And we can see maybe how they look in space. I will show how it looks on TensorBoard in a second so you can understand it more clearly. And the last one is just adding an image. If we add all of this, we can just run the code. We need to let it run for, again, few epochs. And then we can view it again in TensorBoard and you can see what is the output. Okay. The embedding stuff is something that is from this first place. For example, if we have the classic data set of handwritten numbers, we can add some high dimensional latent vector here, like the embeddings. And you can see, like, for example, zeros are here, class 3 is here. And but for us, if we load it now, we have the run curves. We have images. You can see how they change from epoch to epoch. You can iterate through them. And we have a button called projector, where we can see our data. It's not doing a pretty good job, but you can visualize some information that is like high dimensional. For example, we have 30 dimensions on the output because we have 30 classes. And we want to somehow see it in an understandable way for humans. So here in the bottom, we have different algorithms that try to reduce the dimensions and split the classes. You can see this is like this is optimization. It's learning on real time, trying to fit the data somehow. This is not the correct task to use the projector for, but I'm just showing it that stuff like this is possible for different models that you can make. Is this working for somebody? Everybody?
But it's not as colorful as you are.
What?
It's not as colorful as you are.
Yeah, you need to click color Y and select label. Then it will have colors. Normally, after each epoch, the TensorBoard updates. But it's not showing. Try to load.
projector.
The problem is that projector is like really slow because there's a lot of data. It updates. It's better not to view it in real time while you're training the model. It's like mostly afterwards. Yeah, and where you change the labels on the bottom, you can change different algorithms. The UMAP, TSNA, PCA, or add something custom. If you want to see some patterns in the data, the only one you want to use is PCA because it just projects the data. TSNA and UMAP tries to find some distinctions between the data, so it gives you a false confidence that there's something like some clusters formed. Actually, you can see from the color, it's like, oh shit, everything's together, it's not distinct clusters.
To add it to the PyCharm code on this, okay? Is it running on this? Okay, then maybe you start this one.
It's like
Below.
every car of mine is like one project.
It takes some time, sometimes we need to reload it.
Okay. What kind of data is it like I work?
It's the same task we did yesterday.
So I'm capture
Capture images. This is the last layer where we want to classify the letters.
okay, and this line is like green or blue because normally it could be like some kind of information or some kind of stuff to look at, or it's just in space.
In space, this is like this is y-axis and z-axis.
Are they like just looking for some kind of, I don't know, the chance of getting one kind, what kind of letter, or I don't know, the amount of some kind of figures containing, or it's just like
It's like the stuff is a bit of 30 dimensions in the data,
yeah.
and we are using in here PCA already. It's trying to squeeze the data in 3 dimensions, and you can also look at the x-axis is the most important, y-axis is less important. Here you can see. Give me the mouse, I will show it right on the big screen. What is the variance between each axis? And you can select because mostly the first axis has most variance and stuff like that.
Okay.
Yeah, so this. So if you go here to the PCA, the change here you can see that there are different components. Mostly when visualizing high dimensional data, it's not all equal. If you have 2 axes like 2D plot, x and y axes are not the same. X is more important than y axis always. So the idea was just to view that we can do it. It's already 1 hour gone, so now we have to go to the high performance computing. Yeah, error. Problem.
It doesn't like the space in there.
How can we change it? Because for terminal working, the spaces are always a problem. Still nothing is working?
Not working.
Something wrong.
Yeah, I tried to ignore the unresolved import plans. I will leave it there. I will just. It won't work today. Are we going to do something different later on, or are we going to continue working with that one?
No, we're switching to something different. And
no,
in the
Captcha, I think.
yeah.
Mac is typically very secure, meaning that it blocks a ton of different packages and libraries so in the background, and you have to always consent that you're fine with using it.
Yeah, and this is the new one, the M1.
Yeah.
They had a lot of problems. I know Eval's bought an M1, and it's like a lot of the packages are not available on the new Macs.
Yeah, it's also.
And it's like a really pain in the ass. You have to install the old ones that are much slower than they were before, and it's like. So basically, what we did here is that we can see like the scalar values that we have, like loss function, loss accuracy. We have images. I think if I reload it, yeah, it's even going forward. It's more data. It's even more accurate. Another thing is, we probably have only one run, so we won't see it. Here is a tab called argparse. Yeah, it's not as good because it's one run, but if you have, for example, tens of runs with different like batch sizes or learning rates, you can see like parallel coordinate view or scatter plot view. It's like it's looking bad because here you can see that there are some dots over in the middle, but if there are more runs, it's more information. For example, how does the learning rate affect accuracy? And it will show like lower learning rate is lower accuracy, higher is higher, and you can like easily distinguish between multiple results, because on real projects in AI it's like at least 1,000 runs, and going through each of them manually is like really bad. Okay, this was the TensorBoard stuff, so we can monitor the progress while we're away. It's running on some servers or something. Now let's look at some servers. Where can I get the image? Probably. Oh fuck! I again did this.
Is it fine if I just upload the screenshot that I can't install it or something?
Yeah, probably. This is the wrong one. This. So basically what we're looking at now is a high performance computer. Like the architecture, we'll be logging onto it and trying to do something. High performance computers are like huge server rooms with a lot of stuff happening there. I will get the image of how the one we have looks. Probably where each of one you lives, there's something like this available, but mostly in universities. This is the one we have in RTU. So the idea is that high performance computers consists of multiple computers like stitched together, and there's need to be some unit like access system. So how it's constructed here is that we have the head node. It's like the weakest node in the system. It's like a regular computer. It's like really bad, but it's all, you don't run any tasks on it, don't do any work. It's only for accessing the data. We will be logging onto it, and there it's like it has interconnection. Like the internet cables there are like optics, 100 gigabits per second between the servers, so it's like really fast. Downloading data from outside is slower, but inside it's really fast. And it has network attached storage. Now it's approximately 800 terabytes to store the data. And it has a lot of servers, and each of them has 1 terabyte of SSDs. It's like temporary storage. If you want to use a lot of data and quickly, maybe the 100 gigabits per second is too slow for you, and you want to copy it locally to use it from SSD. So what we'll be doing today is logging onto the high performance computer and trying to run the tasks we made today. We'll run the model there and see the results through the TensorBoard. That is the plan now. I will open another task.
Do you use it for research purposes only, or do you also offer services or provide services for industry?
industry, there are some deals. I'm like, you need to speak to the main guy, but officially they allow. But there's like, it's much better price than using some Amazon cloud service or Google Cloud, because those are like really expensive. Using Amazon or Google Cloud is like, I think in 1 month you spend as much money as just buying a server.
Depends on the service, right?
No, that if you want to use something with a good GPU, because they cost, like, if you want some good GPU on the server, it's like €5 per hour, and you leave it running for a week, and it's a lot of money. And it was going up. But the one thing, we have our own servers where we work, but the problem is like server 3 is down, and you spend the whole day trying to figure out, did the RAM stick die? What happened? You can't access. Sometimes internet goes out. If you have like web services or this HPC, it's like all that problems are not your problems. You're paying for something, and they need to provide the service. So if you go to the last task, there is the login information for you.
We can submit the
Last one, yeah. Last one you can submit. Is anybody familiar with Putty, SSH, FileZilla, some of these programs? Yes, no, yes, no. So SSH is how you get into a different machine. All of you should have a program called Putty installed. And there we need to add the information that is written in the task. How can I open and show it? I'll get this one. So if you open, we have a little bit different program, but if you open the Putty, it should be available for all of you. I think it's not for you. Well, it's in this format.
Yeah, it's the GRU installers only for Mac.
Oh, okay.
Why didn't they just tell us yesterday it's so Putty? So we could have done it before and not now in class.
Yeah, but they're installed on the big PCs.
Yeah, but they also said to us before the course started, it would be nice if you bring your own laptop.
Okay, but I think it's written in today's materials, probably. Yeah, Stefan didn't tell. But it should be installed on computer, Putty, FileZilla, WinSCP, anything you want from those. So here, you can add the address in top, hostname. You have it available in the task description. It's ui1hpc.rtu.lv. And after that, you go to the connection data, and then you write the username, abstract01, and then auto login password. I don't know if it's in.
What's the host name?
What? You go to the classroom. No, not this classroom where the tasks are. Okay, 3, blah, blah. Yeah, sure. You have because I don't want to put it on the big screen, because it's streaming, and YouTube is kind of strange because it recommends for all the people that were seeing the stream, for example, 2 years ago were seeing it, recommended them now. So showing that your password is kind of bad. After this, you go to the connection data. So you don't need to add password here, I think. You can go back to the session. Save. And the connection data. Save and open. Set. So here you add password. For you, for putty, you don't have password here. You add this, you add the user, you go back to the session. I'll show it here. Once you added the username, you go to the session, you write some name, what you want. For me, it's HPC abstract. You press save. And after you save it, you just click open. And once you click open, it will ask for password. You just copy it in and you should be logged on.
Need to try it in a program, FileZilla.
Does putty is working?
Yeah. It's not, I think it's Windows and Linux exclusively. So.
Okay, you can open just terminal, I think.
Yeah, there's this interface. But,
okay, here it's the same. You open the password.
No, another pass.
Where do I need to paste it?
Open the FileZilla. Yeah, just server name, that's the feed, that's the username,
okay.
that's the password. Down one.
Yes, there's access denied. Need that password. Yeah.
Hast du die Leerzeit?
I don't think putty works. So everybody who's been working on Linux, if you copy in terminal with Ctrl-Shift-V, it's not working. You need right click. Right click is paste on putty.
So
Here
I
you have
want
my name. Ready to go. Go here. The login is available. Login, password, user and password. Here is an IP. And here is the user. And then you can save.
Do you know how it works in PyCharm? Because if I said or wrote, it also works in PyCharm using the plugin. So we just
The FileZilla is working for you?
no, it's not. Because the time limit is always exceeded. Control?
Yeah. Okay.
It's unknown. Can't
Yeah, you can know what's the IP address. It's your.
Okay.
It's there, and then you should maybe open the terminal. You should maybe SSH into it. Click file.
Try.
Okay, I got it working. You add SSH, then you add the IP address that will show the classroom.
you have like 10 seconds when you don't see anything.
Choose
One member place the windows where you can and then the time.
see, then dash L.
Yeah. And I reinstall everything just after he does this flow. No,
Yeah.
it was perfectly fine.
The line and L.
Yeah,
And
this
this one.
Which one?
This line is dash.
The hyphen.
I don't like
L.
I personally prefer
I
like
believe that's L. Space. Then you add the username. Abstract colon. This press enter. Yes. Now you copy the password.
Are you sure it's the password you gave us? Because I think it's security verified, so I need to give my last password.
Because open machines
I think so.
errors which are only showing the
Because normally the key symbol shows.
on my
Okay.
Okay, so I hope everybody can now log on. This is the thing you see now. You're logged on to the high performance computer. There are a few commands we can go through. It's like main rule of these systems is that, like, for example, you're working on Linux or something, you just execute something, bash, run, and the script you want. You never do this here because there's like a layer. This one is called PBS, that is like managing all the tasks because there can be hundreds of users running thousands of tasks, and it sees like you put your task in the list first, so it goes first. You want only GPUs, you want only CPUs, you need that much memory and all that stuff. There's like a lot of stuff underneath. If you write the command show queue, you can see that these are all the tasks that are currently running. Like you can see the username who run them and how many processors it's using. Underneath here is like the wait, it's not showing the full one. If I do it like this, okay, I'll do it like this. Here it shows eligible jobs. It's like the ones that are standing in the line. For example, you want 4 GPUs, but all 4 GPUs, the servers who have 4 GPUs are busy, so your tasks are standing in the line. Blocked ones are if you do some shit. He will just block your username, so you can't run anything more. And because this is like some people use it in the industry, we have command man balance, and it shows how many monies we have left. For example, here it's 900. I think it's in euros or some abstract credits or something. This is the value you can, and there's like price for everything. But for research purposes, it's like the balance runs out. You write to them, hey, add another few thousand. It's like, it's okay. And this is like a test account, so we have infinite credits as well. So basically, the most important command is qstat. Qstat is, it brings out what tasks you have running. You don't have anything now. And the show queue, if you run it, you can see all the tasks. Your tasks will be shown here. If you want to see more information about the task, you show show queue R, and it will show. Well, maybe make it bigger. It's not working like that. It will show where each task is on which node, because there are a lot of nodes. This is only the master node. So let's create our own workspace. For example, if you write ls, you can, or dir, you will see all the directories available. What we do now is write mkdir. We're gonna create our own directory. You write your own name. For me, it's Walter Svecins. You write your name, make there, and it will create it. And then you can write command cd to go into that directory. Because this is shared account, we will create the directory for each one of us, so we don't get confused who is doing what. Okay, did you create your own folder? Yes? Okay. So now the other thing is, this is the login that we can run commands, do all that stuff. Now we want to copy some data. You all should have installed or have installed like the WinSCP or FileZilla. It's like, if you are, WinSCP is my favorite, but the problem is it's only Windows, and FileZilla is for all the systems you have. So I will just, the problem is that I don't have FileZilla installed here, but if you open it, it will show you that you need to add login credentials. You're already in, right?
I'm already in
FileZilla.
Yeah, but it's installed, but what's the command for the command line? Is it just FileZilla? Or
No, you just run the command. It's like on your PC, it's another program. The one you logged on. On the bottom.
So we're just opening FileZilla.
This one, yeah.
Already go to WinSCP.
So FileZilla is a different program.
Yeah, we're just using from here.
Yeah. This is from this PC that you're using. These are two different programs. One is putty for SSH, and this is for file transfer. And you need to log in with hostname, username, password, and port number. I think it will ask. Always 22, the default one.
but does it make any difference if I logged in via the UI and want to use it via the command line? Probably not, right?
Again?
Does it make any difference if I logged in via the UI, but I want to use it via the command line?
This one doesn't have command line.
If I want to work with FileZilla in the command line,
Yeah.
does it make any difference if I logged in via the UI?
I don't know.
You don't know.
I haven't used that much FileZilla. I'm using the WinSCP. That is like for the Windows.
Or just right.
So basically, what you can do now, if you're logged on, I will challenge this one here. Once you log in, it will look a little bit different, but basically the same. You have the two sides of Windows. Right side always is the server, and the left side is yours. So on the right side, I will open my folder that I created. You open yours. This is like the fastest way if you're like, you can use command lines if you want, but this is the way to copy like easily the data between the server and your computer. Yep. Yeah. So here in the right screen, you can select a folder. Select the one with your name.
But one is, if it's not there,
Yeah.
I think I have to refresh, but on the right screen. There's no F. It's
Here.
No, that's the
This one. This one. But you need to click into the abstract 0. Yeah, here.
You can find it?
Yeah. No, it's
So no, on the left side you can find your files. Find the place where you're writing the code in PyCharm, and you can copy the Py file that you have wrote today to the server. Copy on the left side. Find the folder where you. This is your same. Find where you're writing the code.
And copy the last sentence.
The one you're closing now. You copy it to the first graph. Yeah. Found the one? So here
Just the
5.
yeah. See your you can click on the folder.
Felix,
Ja.
ich habe einen Code in dem Tensorboard. Ich glaube, ich habe das wieder gehabt.
Yeah, it's not. And if you have copied the file, once you go back to the putty, then you can write, if you're inside your folder, you can write ls, and it will, your file will show up.
But we're copying only one
One file.
only this one file. Yeah.
One file. The one you're writing to the. Yeah, this is shows how in the directory. Yeah.
Die hast du bei uns schon. Den ich schon geschrieben.
Copy.
Glaube ich. Bitte? Ja, das geht auch. Und wenn du noch die URL gibst.
That's why you can do stuff like islands.
Sehr gut, danke.
The small seats are not. Oh, so it's like they are buried, but because there's a bunch of small lights around them, they're not. Because I know that you can other than for these nuts.
Kannst du mir den Text einfach, also den Code einfach kopieren als Nachricht, weil ich kann die Datei nicht öffnen.
You can have other people.
Mein Mac blockiert irgendwie jede zweite Nachricht.
I guess you're
Another thing you need to get is from the last task I opened. There is another template that is called 82 hpc run.sh. So you can open this file.
Did you upload it? Or
What?
did you upload it to Classroom?
Yeah, 8.3. Where you got the login data, there should be a file. So normally you just run like the stuff you want. For example, you go to the directory, make some commands, execute or Python script if you want from bash files. Here it's a bit different because we are working with the HPC system. Here you can see all these are arguments for HPC. Here are like where we write the logs. Maybe I can copy all of this to the Jamboard and right there so you can understand better. So this one is why is it doing like that? Like this. So this is just output that is written in files. You show where you want to write them. That is the first thing. Another thing, this is like the queue is like there are different queues you can use. We will use just this batch one. The idea is that there are fast lanes. If you want, like, for example, a short task, but it has like really high priority. If, for example, I will have these batch ones, these are normal tasks. It's up to 96 hours of runtime. But for example, I have my tasks, they're queued up. And some of you want, like, I have this small script, I want to run it immediately. You just change the queue to the fast one and it will go in front of my tasks because it's like shorter task. This one is the most important one. Here you define the specifications you want for the servers you need. For example, now nodes is how many servers you need. PPN is how many CPUs you need. GPUs is how many GPUs you need. And a feature is like some of the servers have a specific like features available. For example, if you have just normal, you can maybe like features you want Xeon CPUs. Maybe you want different CPUs. Here it's a GPU feature, V100. Another available are it's K40 or this V100. After the last update, K40 is not working anymore, at least for me. But we will use the V100. And here you add the RAM you need. The RAM mostly is calculated that we have CPUs times 5 gigabytes. This is how we calculate how many RAM is available to us. Because all of the servers have 5 gigabytes of RAM for each CPU core. So if, for example, I only use half of the machine, I only need, for example, from 8 CPUs, I need only 4, and I write 40 gigabytes of RAM, other people can access the CPUs, but they don't have any memory left. So this is a thumb like rule how we operate here. This is like the standard wall time. After this time, your task will be finished. Even if it's still running, the system will just throw it out, because I once had like a really long model that I wanted to train. One epoch was like 2 days. It was really a pain in the ass to train on this HPC, because every 96 hours it was dropping and I needed to continue and all the time. The FileZilla, I think, is only for us added. It's like that we show that we are for research purposes, like for learning purposes, so we won't stand in the queue. They will let us through. And the next one is the run name. As we are using shared account, you just use your name here. And if we go back to if you go back here, you can change the student name to your name. I think call it the same way you called the folder you had. Next thing, this is to load the conda environment with all the libraries. It's like we make so we can activate the conda diseval is, then we export the library path and all that stuff, so we can access the PyTorch, sensor boards, everything else. We are using an environment called Martisan. This is one of my colleagues, and the problem was that, again, after the last update, they broke all of our environments. The same that happened to you today, that everything broke. So here you add, again, CD is going into the folder. I want to go into my folder, Water Sweatins. You add yours. It should be the same as this PBS and the Python main. This is you will execute a Python script, but you need to change the name of the file you copied to the server. For me, it is 82 tensorboard live py. So here you can add some arguments. If you go to your script, on top you had this argparse. These are the arguments you can change from the bash script. For example, what I want to change is this run name. I can just go here, add a line, run name, and write how I want to call it. For example, this will be for me like test run. It will create a directory called test run for me, where it will save the results. You can go back to your FileZilla after you've written all this and copy in your shell file. Change a bit of stuff in here. Okay, so you should have your files there, and there was an option. Oh. So if you write ls, you can see that I have 2 files available. The one thing is that for now you can't run it because for all files you have permissions that you can run and can't. So we will write chmod, this is change mode. We will write +x, and you need to write the file name of your sh file. For me, it's like this. That means that x is that I allowed the execution of the file, because otherwise it will just drop out an error and nothing will work. I think the other way to do it.
Do we need to add both files, also the configuration of the shell script?
What?
Do we need to add both files, only the Python script, or also
the change mode? Or just add to the server?
Yeah, for that command, do we need to add only the configuration?
Only the sh file, yeah. The Python script we don't care about. And another thing is how you can do it. If you want to do it like not through the terminal, you can just I'll open on my side here. you can just right click, you have properties, and it's not showing again. God damn it. I will copy an image and put it on the Jamboard. You should be seeing something like this. If you right click properties, you can change the permissions, write, read, write, and execute. If you add +X, it will allow execution for everybody. It's like owner, group, and others. It should be available now. So I think the next thing is we care about how do we run the stuff we want to run. So before we had to check the task, we had qstat. Now we have qsub. Qsub, you're in your own directory. You can write a2 hpc like this. It's like q submit and the task name. I will press enter, and if I put qstat, I can see that my task is inside the queue. And if any of you else does it, it will show up for me as well, because yep, we are now 3 that have run our task, and we need to wait. If they don't die, hopefully they don't die. Okay. And if you put qstat, you see your name, and it's the S is C. That means it's completed. That means probably that it just died. For us rest, you can see that it's running. At least my is running. 2 of them have finished. And they have finished probably because they just died. The next thing is, if your task just disappear. Yeah.
What's with VR and the CNN?
What?
VR.
There are different things. For example, if it showed here queue, that means that it's still waiting in the queue. R is running, C is completed.
Okay.
For some of you, it's completed because it died. So we'll go to check it. For example, if I'm here, I want to open this, and for me, the folder created, and it's doing all the stuff it needs to do. It's going through the epochs and training. But for rest of you, you were inside the folder of your name. You go one directory back, and there's a directory called logs. And there you can find the logs you have. So Peter, what is the problem? The problem is run name. So what was the problem? Okay, there is a space between. Oh, it's not showing again. God damn it. I will quickly change it to the editor here. So you can open the log file and see what is the problem. So here you can see that the problem is that he put a space between the line and the run name. So it doesn't know how to interpret. You need to like remove the line like this, and then it will run. So for example, if your task fails, you can come always here and see what was the problem to the logs.
Where's the log folder? In probably you don't know this program as well.
What?
Probably you can't tell because it's FileZilla, right?
So this is your folder, right? It's in the abstract. Here you can see
So probably mine didn't run. Is it just K keys up and then the
This is what you run.
yeah and then
Line. Yeah, run name.
run name?
Yeah.
Just for running.
No, do you need to write run name like this? Run underscore name, then space, then you write how you want to call. The problem is
I think it's just R and not run name, right? For Mac.
no. Here, sorry. Here you don't have the argument. You have like this, and the place you edited.
Yeah, pattern.
Yes. Here you have the run. Yeah. So there you just put like a bit
And then
without anything, just the path and that's all.
Yes.
That's it.
This part?
No, the one you did already. That's all.
Okay.
And you put use that. Command use that.
Tuesday?
Yeah.
Like that?
Yeah. Enter. And where is yours? Go back to the other one. Okay, you have everything there. Open the folders in FileZilla. Refresh this. Refresh. It's not showing. And in your, if you go into your folder, refresh this one. It's writing the internal files here. Move this down. Extend this part. No. This one here. Like the size. You want the size to be right? Yeah. Okay. It's not showing. Those should be probably error files or something. You can open them. Here. Yep.
Times two. Wait, there's a queue. How many
I'm overwriting and to open it.
Come on, guys. Be
There's
fast.
no
Wait for the queue.
Need to probably copy it.
Yeah.
So for everybody, tasks are going or they're failing.
Running.
You see in your folder that you have a sequence like the folder created, or no? If you refresh this one, yeah, you have it. It's going. If you refresh yours, okay, it's running through it now.
What made it?
You need to open it. Yeah, it's going. For you? And this one?
So now we just wait time. I mean, working with that time is 2 days working hard, and then I guess I cannot.
You can just leave it. For example, your run
Just enough.
is not.
2 days
Okay.
working
You put another one. Yes, you fixed it and run. Yeah, that finished. It's no longer here because there's nothing to see. So that's all. And this one is running, and you should see here if you go to your folder. Yeah, so the sequence there. Yeah, that's good. For you, it's running.
Yeah.
Okay. Another thing we can quickly check. If we go here, For example, I'll put it full screen so I can see because it's not scaling properly. If you put show QR -R, the proper like this, show QR, you can see a lot of runs with our names. Abstract 01. It's not showing here. Like this. Abstract 01. Like this. You can see them, and you see that the node name is VN60. What we can do now is SSH VN60. We can go into that node. Now we are not in the main node, the UI node. We are inside one of the powerful nodes. And here, for example, if we want to see what is happening, to monitor the GPU, the command is NVIDIA SMI. If you run NVIDIA SMI, it will print out something like this. You can see that our model is running, how much memory it uses, and all this stuff. Another program you should probably know if you've worked with Linux is EdgeTop. You can see what is happening here. And here you can see that it's not scaling properly, but these are all our runs. A2 tensorboard template. You can see that actually something is training. You can see, okay, the CPU usage is only 1 core to the max, and 22 gigabytes of RAM is used. This is how you can monitor all this stuff, if it's actually going, if maybe sometimes you have some problems and it shows that it's working, but actually it's frozen or something. And to log out from this node that we went into, you can just write log out. And we're back into the UI node. One more thing we probably won't set up. There is a thing called SSH tunneling. It's port forwarding. The idea is that, for example, before we looked at the TensorBoard here, it won't load because I already closed it, but it's locally on the port 6006. But I want to see what's happening on the HPC. The problem is, what I could do is through the FileZilla download all the data every time. That doesn't seem like a good idea. Then what you can do, I have already set it up. You don't have it working now. You can write the TensorBoard logdir here, and add your local one. It won't work for you, but you can set it up if you want. And you can see. Okay, this is the wrong window. This one. That it works for me from the HPC or any other server. It shows up on my PC.
And where did you get the path from? You just copied in there?
The path?
Yeah.
The path is the path inside the server. Like
It's like the same path we put inside the Python script.
That didn't work for me.
Oh.
It didn't generate. It didn't generate. So I thought now, since I don't need the script anymore, maybe I can generate it somewhere else.
I think in maybe FileZilla you can copy it, but it's like home, abstract, and this is the path you need. But it won't work for you because you don't have a tunnel item.
What?
Okay, I'll quickly add. I will show for everybody
What do I not have?
a tunnel, SSH tunnel. So I will show for everybody except you, because you have a different problem. You're running it through not putty. So if we go here, you saved your configuration. You can load it. You have your username, the IP address here. You have username, and if you put a SSH here on the side, go under tunnels. Here you can add, and here you add the source port what you want. I don't know why I started always using 8024, and in the bottom you add 127.0.0.1 and port number 6006. So the idea is that this is the destination. On the server side, 127.0.0.1 is localhost. So localhost, this port, is forwarded to my PC's 8024 port. That's the idea, that I can open tensorboard inside the server on this port and open on my PC using this port. I can forward the ports between the PCs. And even if you want, I sometimes did it like the main node of HPC is too slow. So I go in with a tunnel in the server, then I use another tunnel to go in some node, like we used VN60. So I have multiple tunnels in line, so I can view the tensorboard more quickly. If you want this, we can, and log in. The tensorboard command should be working for you, and you should be seeing on the web browser the data.
So we should close like
the previous window you should close and log in again then if you set this. But it's actually like, I'm not sure why there's some problems, because 127.0.0.1 is localhost, and writing localhost is localhost, but it only works with 127.0.1, not with localhost. I don't know. And for you, I will quickly check. You run it on the
locals, not the IP address, just locals.
No. You need port forwarding going to the browser. You have drive SSH port forwarding.
Or just
No, just write. There will be some programs port forwarding. What you need to do is open it. Yeah, something like this. That locally you want 80, and from this server you want this one. Then it's like, but you need to write the correct ports, and that's the way of quickly check it out. It's working. You can see it or no?
No, I have facts in mind.
Copy that.
Yeah, not
Correctly.
have to do again.
For logging inside this one. But we need to save it. If you write it, no. Save it, no. And then you can log on. Yeah. Then you can just insert app. Or log here. Then we go to FileZilla. You can do this.
in local, not on local conflicts, but you can write 1 to 7, 0, 1, and then it's actually 4. Maybe? You wrote something different.
I absolutely don't know why it doesn't work. Like, maybe work last time.
So this one local cost now it will be 1.7 1 and 4 is the and so you can not copying the data, see exactly from there.
What were the other parameters again? What's the Captchas and then?
Support, and then it's like
But is it important for the further lesson? Do we need it?
What?
Do we need it for the rest of the lesson? Or?
No.
Okay.
Okay, this is just how you can access it with port forwarding.
What are we going to do for the rest of the day?
Rest of the day, another guy will come. I will be leaving at her work stuff, and there will be Selenium.
But do we need to submit something for that?
For this one?
Yeah.
Kinda, yeah.
What
The TensorBoard output, like from the images from TensorBoard,
what should I submit?
that it's not running, right?
Yeah. What exactly?
That it's like the that your conda environment broke, and you can.
Yeah. What exactly do you want to see? I mean, you are responsible for grading, so what should I submit for you?
You just write that the conda environment broke and you can access it, and
I will just
maybe next guy is more
know if the command terminal how to get there. Maybe he can show me how to get in what
Or should I just leave a message for you?
in the submission, yeah. There is submit.
So you don't need a screenshot that it's broken.
Yeah, yeah.
It's fine. Okay.
Okay. There are screenshots in the Jamboard together.
Well, I think it's time for lunch.
Now we have to wait in the queue. They are already there.
One question: is it possible to like see the room with all of the HTC, like all of this stuff? Because the card is like very cool place.
We're
It's
going to
like
do it.
high security or something.
We're going to do it at 3 p.m. Because they need
Are you going to see the robots? I'm not sure if I'm going to see this. Yeah.
For HPC, I think it's better that I haven't thought. I can ask tomorrow. Will be
Yeah, but we got the campus tour today, so maybe you're going here. But I'm just curious. It's like it's even possible. It's like absolutely no.
probably possible, but you just need to ask when you're going.
Yeah, I mean,
Maybe
you are
can
going
see
to
the HPC because I actually haven't been there myself.
I heard it's cool place. I don't know.
I haven't gone there
Maybe
because
you should go fast. Or something.
because this is like the computer faculty just moved like last semester here. This building was open before the HPC was here, but our faculty was over the other side of the Algoma, so I never actually came there to see. What?
If we can ask them where we have events to.
You're going on a tour with
Yeah,
with
today.
whom?
We don't know. Some
Yeah,
guy
so
from robots.
they organize some kind of tour to see the robot stuff and things.
Yeah,
Do
because
you
I
know a
can't-
name or no?
Not yet. I mean, if we can get your WhatsApp number or something, we can ask at the tour if we are going here or no, and if we can go there, we can like message you, and then tomorrow or something.
Okay, you can ask the tour.
Yeah.
Else, I think the best solution is like I don't need to give number. Tomorrow will be else.
Yeah.
He's been there. Like he's in good contact with the guy who's running the place, so he
So
can
it would
probably.
be like possible to like.
Yeah, I will write to Evalds if there's need. Maybe he can arrange for tomorrow.